Hi folks, welcome back. This is Math 2, Unit 6, Lesson 6.7. We are on Activity 2, Proving Properties of Parallelograms. We're going to start with the first question here. Write the equation of a line parallel to y equals 2x plus 3, passing through the point -4, 1. So there's a few pieces of this that we need to take into account, right? We want to write the equation of a line that's parallel, and it has to pass through this point. So a key thing that we should be thinking about here is that parallel lines have the same slope, right? We just proved that in our previous activity. So keeping this in mind, right, we need to pretty much use the same slope from this equation in the new equation that we write. So the equation y equals 2x plus 3, and I'm going to do an arrow right over here and write it again, y equals 2x plus 3. This looks like it is written in the slope-intercept form, and you all would probably recognize this as y equals mx plus b, okay, where m, and I'm going to just kind of shade that in here, m represents our slope. So in this case, our slope is 2, so I'm going to write m equals 2. Okay, so we've gotten part of this already. We found the slope has to be 2 for this new equation that we write. The next thing that we can be thinking about is the type of, the form of equation that we want to use, right? Here we use slope-intercept. The other type of equation that you all learned earlier this week is the point-slope form. So the point-slope form looks like this. We've got y minus y1 equals m times x minus x1. And as you can guess from the name, this form of equation is most useful when you are given a point and a slope. And in this case, we've got our slope of 2 and then our point of -4, 1. Okay, and then the x1 and the y1, those are just the x and y coordinates of your given point. So I am going to shade, like we've got this x coordinate here in purple, and then I will put this y coordinate in green. So let's set up this equation. So we have y minus, my y coordinate is 1. So I'm going to put y minus 1 equals, we know our slope is 2 because this new equation, right, the line that goes through this new equation has to be parallel to this one. So I will plug in 2 for m, and then we have x minus, and in purple is our x coordinate. So this x1 represents our x coordinate. And so our x coordinate is -4, so I'm going to write x minus, -4. Okay, so this is our setup. Now let's start to simplify this. So the first thing that we can do to simplify is to just take care of the subtracting a negative. So we've got y minus 1 equals 2 times x, and then if we're subtracting a negative, right, that becomes a positive, we're adding, so x plus 4. Okay, so after this step, right, we see that the 2 is right in front of the x plus 4, right, and it's being multiplied. So we can distribute the 2 to both of these numbers, so we end up with our 2x, so 2 times x is 2x plus, and then we know that 2 times 4 is 8. So that's on the right side of the equation. We still have the y minus 1. Okay, Now it's starting to look a little bit closer to the slope-intercept form. So let's see how we can get the y to be by itself, right? We want the y on the left side. So we can move this one over to the other by adding it. So -1 plus 1, right? -1 plus 1 is 0. That cancels out. And we're left with y equals 2x plus, and then 8 plus 1 here is 9. Okay, so we have now written our equation of a line that is parallel to y equals 2x plus 3, right? You'll notice that the slopes are the same here, which tells us they are parallel lines, and it is passing through the point -4, 1.